Students. Today we are going to be starting our unit on transformations. More specifically, we're going to talk about one specific type of transformation today, and that is reflections. Now before we do that, let's start back at the beginning, at what exactly a transformation is. When we talk about a transformation, the book definition of a transformation is an operation that maps. Okay, so it's an operation that maps. Now when you see the word maps, don't let that confuse you. The word maps just means moves. So it's an operation that maps or moves a pre-image onto an image. Now I know that sounds kind of like fancy wording, so let's go back and talk about this. When I say a pre-image is our original figure. So let's take this point up here. I'm going to call this point A. That point A is going to be our pre-image. Alright, and this point over here, we're going to call this A prime. That is our image, or our new figure. So what a transformation does is how do we move our pre-image, or point A, to our image, or point A prime. So when you see the word pre-image, that just means original figure. And when we see the word image, that refers to our new figure. Now, there are three types of transformations that we're going to talk about in this unit. First is reflection. The second is rotation. So let's write these down. So we have reflections, and that's what we're doing today. We have rotations, which we'll do tomorrow. And then lastly, we're going to have translations. So these are our three types of transformations, or three types of ways that we move points or figures from one place, our pre-image, to the next place, our image. Now when you think of a reflection here, think of a reflection as like a mirror. Okay? A reflection is, I'm just going to write, it's a mirror. A perfect example of a reflection is standing in front of a mirror. When you stand in front of a mirror, you represent the pre-image, or the original figure, and your reflection, or what you're looking at, represents the image. So when we think about a reflection, okay, a reflection is a mirror, or in other words, it uses a line that acts like a mirror. I'm going to say uses a line that acts like a mirror. So for example, let's take this line right here. This is going to be our reflection line. A reflection line is what you're reflecting your image over. And like I mentioned a second ago, a reflection line simply acts like a mirror. So if I have this point, we'll call that point A, and I reflect it over this line, it would end up right there. And we call that our image. Or that'll be called A prime. So this line right here is called our reflection line. Now, one part of reflections, or a type of, or a vocab word that goes along with reflections, is what we call our line of symmetry. Now, different figures have different amounts of lines of symmetry. So when we talk about a line of symmetry, okay, a line of symmetry for a figure, okay, is a line in which, when the figure is reflected, a line in which, when the figure is reflected, it creates an image of itself. running out of room here, an image of itself. Okay, so for example, if I were to draw this shape right here, okay, I'm just going to draw a triangle. Okay, this triangle has one line of symmetry because there's only one line that I could draw through this triangle that would create an equal triangle or a symmetrical triangle on both sides of the line. Now I know it doesn't look like it from here because it's hard to draw on this piece of software, but if I were to draw this image or this line through this triangle, it would create two identical triangles or two symmetrical triangles on both sides. Okay, let's try this again. Let me try to attempt to draw a square up here. If I were to ask you how many lines of symmetry this square has, well, there'd be one right here, because these two halves are identical. There would be a line of symmetry that goes through these two vertices, because that would create two identical shapes on both sides of this line. Likewise with this vertice, and there'd also be a line of symmetry right there. So a line of symmetry is any line that you can draw through a figure that creates symmetrical parts on both sides of the line. Alright, let's keep going down here and get more into the idea of reflections. You'll see two examples of reflections here. Again, as we mentioned earlier, this line right here represents our reflection line. Okay, so this is a reflection line. Same thing here. And these two shapes are being reflected over that line. So here you see this heart being reflected over the reflection line. Notice it's the same distance from the line. Okay, so the distance from here to the line is going to be the same as the distance from here to the line. And over here the arrow is being reflected vertically over the reflection line. Okay, so you notice the distance from this vertice to the reflection line is the same as the distance from this vertice to the reflection line, and so on and so forth. The distance from this vertice to the reflection line is going to be the same as the distance from this vertice to the reflection line. So notice the arrow is the same distance from the reflection line as the arrow on the opposite side of the line. So if this was our original image, we would call this our pre-image. So this would be called our pre-image, and this would be called our image. Let's do some examples here. Number one says if point A, and then it tells us where that point is, so let's go ahead and plot that. Here's our y-axis, and here's our x-axis. So if I were to go and plot the point 2, 3, or 2, negative 3, I'm sorry, it would be 2 and then down 1, 2, 3. Right there. Okay. Let's try to draw these lines a little bit better. So there's our x-axis, and here's our y-axis. Alright, so there's my point, 2, negative 3, and it says if it's reflected over the x-axis, it wants to know where the point would end up. So if I reflect this point over my x-axis here, where's my new point going to be? Well, let's count how the distance from this point to the x-axis would be 1, 2, 3. So then I have to go 3 points beyond the x-axis. 1, 2, 3. So my new point, or my image, would end up right here. Call that A prime. So my new point, where is A prime? It would be 1, 2, up 1, 2, 3. So it would be 2, 3. Okay, now it wants me to reflect it over the y-axis. Alright, let's try to straighten this line out a little bit here. Okay. There we go. Alright, so now it wants me to reflect this same point. So again, remember, this is my original A, the point 2, negative 3, but now it wants me to reflect it over the y-axis. So again, I'm going to count the distance from here to the y-axis, which would be 1, 2, and then I'm going to go 2 points beyond that, so 1, 2. So if I reflect point A over the y-axis, I'm going to get this point. So we'll call this our A prime, our new A. This is my original A. In problem 1, this was my A prime, my new image. In problem 2, this is my new image because I'm reflecting it over the y-axis. So the coordinates of A prime and number 2 would be left, 1, 2, and down, 1, 2, 3. So negative 2, negative 3. Alright, what does problem 3 ask? Problem 3 says if A is equal, or if A is the point 2, negative 3, so we're still sticking with our original point right here, is reflected, but now it says if it's reflected over the line y equals 1. Okay, so we have to go back to algebra. Our line y equals 1 would be, remember, you go up 1, and it would be right here. So now, instead of reflecting it over the x-axis, or over the y-axis, we're reflecting it over the line y is equal to 1. So again, I'm starting with 2, negative 3, because that's the point it tells me to start with. And if I'm reflecting it over this light green line here, or the line y equals 1, I'm going to count the distance to that. So 1, 2, 3, 4. Then I have to go 4 points beyond that. So 1, 2, 3, 4. So that's where my new point would be. So if it asks me, or if I need to figure out where that point is, again, I'm going to start at the origin. I'm going to go, alright, 1, 2, and then up, 1, 2, 3, 4, 5. So this point would be at 2, 5. Alright, over 2, up 1, 2, 3, 4, 5. So that's those are examples of how you reflect points. Alright, let's go to the second page here. Okay, it has one more point. So we're going to have to go back to the previous page. It has one more question referring to the previous graph. It says, if A, again, we're starting with our original point, 2, negative 3, but now it wants us to reflect it over the line x equals negative 1. Okay, so if I go back to to my original graph here, the line x equals negative 1, right, is going to be this line. So I go left 1, so the line x equals negative 1 is going to be here. So it wants me to reflect my original point over the line x equals negative 1. So let's do that. So we're going to count the distance from the point to the line we're reflecting it over. So 1, 2, 3. And then we're going to go 3 beyond that. 1, 2, 3. So our new point, or our new A prime, would be right here. So if it wants me to say the coordinates of that point, I'm going to start at the origin, and I'm going to go left 1, 2, 3, 4, and down 1, 2, 3. So it would be negative 4, negative 3 for those coordinates. Our answer here would be negative 4, negative 3. Okay, now we're going to reflect a whole image. So in number 1, we were just numbers 1 through 4, we were reflecting points, and now we're going to be reflecting an entire image. So it says reflect the given image over the given line and label the new coordinates. So if I reflect this image over the y-axis right here, here's my y-axis, and here's my x-axis. I need to reflect each vertice of that image over the y-axis. So I'll start with this vertice. Again, same thing we did before. 1, 2, 3 units to the y-axis, and then 1, 2, 3 units beyond that. And I have to do that for each vertice of my image. So I'm going to do that with this vertice as well now. 1, 2, 3, 4. 1, 2, 3, 4. And I have to do with these two vertices as well. 1, 2, 3, 4. 1, 2, 3, 4. And then last vertice right here, I'm reflecting over the y-axis. I go 1, 2, 3, 4, 5, 6, 7, and then 1, 2, 3, 4, 5, 6, 7. So if I wanted to reflect this whole image over the y-axis, I'm now going to connect my vertices as best as I can. And that would be my reflected image. Now it wants me to, in number 6, it wants me to reflect this same image right here. This is my pre-image. This is my original image. I want to reflect it over the line y is equal to 1. So remember, my line y equals 1 is right here. And now I'm going to do what I did in the previous problem, in number 5, and I'm going to reflect each vertice over this line. So remember, reflecting over the line y equals 1 is different than reflecting over the y-axis. I have to create my own line, which I did here in lime green. So let's reflect each vertice over the line y equals 1. So 1, 2, 1, 2. Make my new vertice. 1, 2, 3, 1, 2, 3. Go to this vertice. 1, 2, 3, 4. 1, 2, 3, 4. And lastly, this vertice. 1, 2, 3, 4. 1, 2, 3. Oops, I'm sorry. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. There we go. Okay, so if I connect my vertices here, that should give me my image. Alright, so that's how we do reflections. If you're doing them on a graph, you count the distance from the vertice to the line of reflection, or your reflection line, which in number 6 is this line y equals 1. In number 5, our reflection line was the y-axis. You count the distance from the vertice to that line, and then you count that distance on the same side, or on the other side of the line as well. Now, on the bottom here, we're going to see a shortcut. So sometimes you won't have a graph available to you. And you could just draw out a graph and do your reflections that way, or you could use a shortcut. So it says here, if I have the point xy and it's reflected on the x-axis, then its image point is going to be x negative y. But if I take that same point and I reflect it in the y-axis, its image point is going to be negative x, y. So for example, if I didn't have a graph here, and I just told you to reflect the point 410 over the x-axis, what would you do? Well, if you didn't have a graph, you could sketch it out, or you could use our shortcut here. So if I take 410 and reflect it over the x-axis, its image point is going to be x. So notice our x's stay the same. It's still going to be 4, but now it's going to be negative 10. Whereas if I take my image and I reflect it over the y-axis, so let's say I were to take the point, well, let's just choose the point 5, negative 3. So I were to take the point 5, negative 3 and reflect it over the y-axis, okay, I can use this shortcut. So it would be negative x, so I would switch that to negative 5. And then the y-coordinate would stay the same. So its image point, if the pre-image was 5, negative 3, the image would be negative 5, negative 3. So the y stays the same. Okay. Let's do some algebra now. Number 7 says find the value of each variable given the diagram and the reflection line. Now, one thing that we need to say about reflections is that when you do a reflection, nothing about the pre-image changes. So none of the measurements change. So when you reflect, it's kind of like when you look in a mirror. If you look in a mirror, you look the same. It's not like your face is bigger or your arm is smaller. Everything looks the same. It's the same thing when you're reflecting images. So if I reflect this image over this reflection line, this distance right here stays the same on both sides of the reflection line. That's why when we refer to reflections, a reflection is what we call an isometry. Because an isometry is when you do a transformation and all the measurements of all the sides stay the same. So if it says find the value of each variable given the diagram and the reflection line, this line right here, okay, when I reflect it over, is going to be the same distance as this line right here. So if I were to solve for x, I would just say 10x minus 2 is equal to 28, because this line right here corresponds with that line right there. And if I go ahead and solve for x, I'm going to get 10x equals 30, or x is equal to 3. Now if I want to solve for y, I have to think to myself, okay, what side, when I reflect it, where does this side end up right here? Well, if I reflect this shape over the reflection line, isn't this side going to end up right here? So if I'm solving for y, I would do 2y plus 5 is equal to 15, and then I would go ahead and solve for y. So subtract 5 from both sides, and we get 2y is equal to 10, so y is equal to 5. Alright, so we have x equals 3 and y is equal to 5. Alright, the last type of problems we're going to do is we're going to go back to what we talked about in the beginning when we talked about lines of symmetry. So what it asks is, how many lines of symmetry do each of these shapes have? Okay, well, it looks like in number 8 we have a square tilted on its side, or what looks like a square. Okay, so our lines of symmetry, remember, are the lines that I can draw through, and again, it might not look accurate on here, but it's the lines that I can draw through that create symmetrical shapes on both sides. So notice this side is the same as this side, so this would be a line of symmetry. Alright, same thing here. That's going to give me a line of symmetry because this shape, or this side of the line and this side of the line are exactly the same. They're symmetrical. Alright, but not only in this shape can I draw those two lines of symmetry, but I can also draw lines of symmetry in this direction. Okay? Because if you pretend for a second that the red line and the green line aren't here, you can see that this shape is the same as that shape, where they're symmetrical on both sides of the black line. And then lastly, I can draw a line of symmetry right here. So this specific shape would have 4 lines of symmetry. Now what about this arrow right here? If I look at this arrow, is this a line of symmetry if I go halfway through there? No, because this side is clearly different than the other side. So the blue line right there is not a line of symmetry. This arrow, in fact, only has one line of symmetry, and that is the line that goes through the arrow and through the point. So this would be a line of symmetry, because this side of the arrow is going to be symmetrical to that side. Alright, now, if we look at this parallelogram right here, or what looks like a parallelogram, let's see if we have any lines of symmetry. If I try to cut it in half this way, is that going to give me a line of symmetry? So when you think of a line of symmetry, so let's go back to the arrow for a second. If you notice, if I reflect this half of the arrow over the blue line, it's going to map or move itself on top of the other arrow. So that's one way you could look at a line of symmetry. If we go back to the square, and if I just look at this blue line, if I reflect this shape right here, or this half of the shape, over the blue arrow, it's going to land on this half. Same thing with the red arrow. If I reflect this half of the shape over the red arrow, it's going to end up on top of this shape. Now, is that the same here with this parallelogram? If I reflect this parallelogram over the black line, is it going to land on top of itself? No. Take this vertice, for example. If I reflect this vertice over the black line, it's not going to end up on this vertice. It's going to end up right here. Okay? So this parallelogram, actually, I don't think it has any lines of symmetry. Let's try cutting it in half the other way. So if I erase that here, and now let's try this. Is it symmetrical on both sides of this black line? I don't think so. No. If I were to reflect this vertex right here over the black line, it's going to end up somewhere out here. So you can see that this parallelogram doesn't have any lines of symmetry. Just to clarify that point, let's try reflecting, or let's try drawing a line through one of the vertices, or through two of the vertices. Well, let's redo that one. That's no good. Alright. Let's try this way here. Okay. Let's see. What do you think? Is this a line of symmetry? Is this side perfectly symmetrical with that side? I don't think so. If I were to reflect this vertex over this line, I think it would probably end up somewhere over here. Okay? So you can see that this parallelogram has 0 lines of symmetry. So we have 0 here. Our answer for number 9 was just 1. And now let's go to our last problem, number 11. Okay, well this to me looks like a regular hexagon, right? 1, 2, 3, 4, 5, 6, a regular hexagon. So anytime you have a regular figure like this, not only you can draw a line of symmetry through each of the sides, so that would be a line of symmetry, and you can also draw it through each of the vertices. So that would be a line of symmetry. Okay. Here's a line of symmetry right there. They have one through the middle here. So that gives us 4 so far, but we're also missing a few. I can draw one through here, and I can draw one through here as best as I can. There we go. All right. And so this specific shape has 1, 2, 3, 4, 5, 6 lines of symmetry. Alright, so that's how we do lines of symmetry, and that's our introduction, or our first unit on reflections. We'll have two more videos on transformations. One coming tomorrow will be rotations, and then we will talk about translations. Please feel free to see me or one of the other honors geometry teachers if you have any questions. Thank you.